Hello all, and in this particular video, I will be teaching you hash map, and we are not going to cover like how a hash map is iterated and all those basic stuff, but this video will mainly focus about the internals of hash map, like how hash map is being implemented in Java and its core internals. That way you can design your own hash map also, or even you can implement your own hash map, kind of, which is asked in interviews, when and it is a one of the favorite question if you are going to give Java interview. So let's start. And as you all know that hashmap implements map interface, and it doesn't implement collection interface. So if you've not seen the previous video where I have shown the collection hierarchy, just go and watch that, and I'll be putting the link itself in the description section. So let's start that. Okay, so we all know that hashmap extends map interface. So you can create hashmap something like this also, like map, and here you need to give that what kind of key it has. So let's take string for simplicity, and let's take the value also as a string, and you can give my map whatever name that will be the reference. Okay, and when we'll allocate memory to the object like this, new hash map, and here again you can put string or even this will work. So what happens internally here is, so this is the reference which will be created on the stack memory. So let's see here that this is a stack memory. Okay, and here let's suppose my map is a reference which is created, and which will point, which will or reference to an object. Let's see this circle as object, which will be a map object. Okay, so consider that this is the hash map object. So we can write this is the hash map object for now. So what is inside this circle, that is the object. We will see that what all things are there inside this particular when you create an object of a hash map. Before that, let's talk about some operations which we frequently perform and why hash map is really important. So it is said that since hash value for the key is calculated, and based on that hash value it retrieves the result or put the data into the hash map, right? So let's talk that what is the time complexity for get and put operation. So get, here you will give key, and for put obviously you will give key value. Okay, so both of these operations are set to take constant time, which is O of 1. But practically, I mean, theoretically, it sounds, yes, it is O of 1 and constant. But what happens in terms of when collision happens, let's suppose, like two keys which have hash which are mapped to same index. We'll talk about this in detail later. Then in that case, to avoid collision, they use something called linked list. Or now from Java 8, this is been, even when certain threshold of collision is crossed, then they uh, convert that into self-balancing binary search tree also to decrease the search complexity. So far you can say this is O of 1, but it's not exactly correct, I'll say. But let's move on that what is inside this object first of all. Okay, so that you will have a clear understanding. So so how does that hash map is being created is, uh, so when you look up the code, it is written in such a way that there is something called you know table, and that table is nothing but a array of type node. What is node here? Node is an inner class written in hashmap class, which extends map dot entry. Okay, so this is something. So how this table is being determined is like defined is something like transient so this will be of node type node table. Okay, how it is being created? It's created like this. So there will be an array of reference table is created. Okay, inside this. Now what happens if you have not initialized your hash map with a capacity? What happens? The default capacity it takes is 16, and that's nothing but means like it will have 16 indexes, 0 1 2 3 4, like this, 15. So this total capacity of this table will be, let's suppose, 16. So you can say that size is equals to 16, which is also called capacity. Okay, so what happens now when you put a data into hash map? So this is being mapped to this particular array itself. How that is being done? So let's suppose you performed some operation, my map dot put, let's take a string key as Ashish. Okay, and let's take value as Gupta itself. To make things simplify, I'm not getting any other good example. So when you do this, so what happens, since this is our key, okay, hash of this particular key is created. And let's not go into that. Let's suppose there is a function which calculates hash of this. So let's suppose that hash, this is just an example, okay, hash of Ashish is let's suppose 19. Okay, so 19, now the indexes are only 50. So what happened? Whatever the hash is being calculated, it is being modulo by its capacity. And since here the capacity is 16, so 19 modulo 16, it will be equal to 3, obviously. So this particular entry which we have done here, this will be mapped to third index. Okay, here, let's suppose. Now what is this entry looks like, or node looks like? So I've told that this is a type of node. So let's talk about what is that type of node. So you remember that here, we'll come back to this later. Let's suppose here for now Ashish is the key and Gupta is the value. For now we'll explain what will happen in detail. So what is this node actually? So node, as I said that node implements map dot entry, right? So not go into that. And what is this node? This node has 4 member variables. First is your key, obviously. The second is obviously your value, correct? And what will be the third entry? Third entry is pretty obvious, it will be hash. What will be the fourth entry, if you should know? So as I talked about earlier, that when there are two hashes whose index is mapped same, right? Then in that case collision happens, and if collision happens, then we must have something which will store the next node of that particular uh, index. So we'll have something called next. If you have read linked list, you already know this stores the address of next node. So this will be of type node itself. Okay, so these four things will be there. So now let's come back to this, and where we have written this, instead of this, let's delete this and create it in a proper way so that you can visualize. So let's take this one. Okay, here you can imagine like this. So key, what was the key? Ashish. What was the value? Gupta. And what was the hash? 19. And since it doesn't have any null, so oh sorry, next, so it will be null. Okay, now let's suppose I again did entry my map dot put, let's take xyz this time, don't waste time to do that, and this xyz, and let's take pqr, and coincidentally the hash of xyz is, let's suppose, equal to 35. So what will happen in this scenario? 35 modulo 16 will be equal to 3 again. So this is the index where it has to be mapped, right? Now again one node will be created, and this will be like this: xyz values pqr, forget this, like this was small, so okay, let's take small itself, otherwise you'll be confused. pqr, and again the hash is 35 and it's not 19 here, so you can see that hash is not same but it's, and this will be null. But this time how will you put this at 0? Because on 0 you already have this entry, so you will now iterate it, this linked list, and this can be big also. Like if let's suppose tomorrow again some hash value comes whose modulo gives you 3, then you will iterate it, and now instead of null, what it will store? It will store the reference memory address of this node. Sorry. Okay, so it will store memory address of this node. So this is how it will be created further. So this is one of the case. This is case one which we were talking about, where your key is not null. You should remember there are two cases. Now if we see a second case, case 2, where key is null, because you know that Hashmap allows a null key. Okay, so if the key is null, you need not to do anything, and you know that this will always be mapped to this one, irrespective of whatever value it has. This will be mapped here, the key will be null. Okay, and whatever value will be there, it will be value, whatever, irrespective of hash, whatever calculated, not calculated. I think since it is null, it will be obviously null, and next element will be null first go. And you know that hash map does not allow duplicate keys, but so this will always be mapped to 0. These are the two cases while you enter the element. So I hope you get it. Like in this particular example only, I have explained that when collision happens, what happens, okay, and when null key happens, what happens. So you understood collision, but here is one more interesting thing. Like let's suppose in the worst case scenario, the linked list kept growing, okay, in this direction. So what will happen here, if size of linked list is grown up to a decided threshold, okay, so what happens from Java 8 onwards, it is handled the collision is further handled, or rather we'll cut here and we'll see collision. Collision is further handled via self balancing binary tree, okay, sorry, binary search tree instead. Why it is being done? Because let's suppose the linked list grows too long, okay, then in the search, okay, when you'll search the linked list, it will be O of k, number of elements, right? Or let's suppose k equal to n, so it will be like O of n. Now when you have something like this, let's suppose this is a self balancing BST. This is the search for this is always O of log long, this is O of log n, okay, so this will reproduce. So that's what I talked about, if you remember here, that although the complexity of search is O of 1, as we can see that, okay, you have calculated hash just retrieved, but if there are multiple collisions happen, it can grow up to of n, and if crosses certain threshold, then it is converted into self-balancing binary search tree, and it will be O of log n. So you might have a question like, if this node is there and only one next is there, so the hash map has taken care, and they have created something called, I think, tree node inside that, but you need not to go into that detail to understand or to explain to interviewer. If you really want, you can go and check OpenJDK Java code. I mean, it is open source and anybody can at least read that. So this is gist of this hash map. Now what happens, one more thing, like there is something called load factor, okay. So what is the load factor actually? Load factor is 75% by default, okay. So what is load factor? It says that, okay, if you have more number of elements, more and more elements are inserted, okay, what happens, it increases obviously collision. So what happens, like if the collision will increase, obviously the search complexity will go down, and even the put complexity will go down, right? Insertion complexity. So hash map increases its capacity, and to increase that capacity, it checks whether the load factor is being you know, the threshold for load factor is uh, crossed. How it is like, so let's suppose the capacity of hash map is now 16. Okay, and what will happen here when, so, and default load factor, let's suppose, is 75%. So what is 75% of 16? 12. Okay, this way. So 12 is the sum. So when the size of hash map is this, okay, so it will automatically regrow its capacity, will increase. So this is the main actually funda of hash map. And how does the capacity grow? So let's suppose if it's I think I'm not very sure, but yes, I think in the code it's like this. This is so new capacity equal to old capacity left shift by 1. Okay, so let's suppose this is 16. Okay, and then when we'll do left shift 16 by 1, it will be like 32. This is a shift operator. If you don't know, you should study the let's give you an example of this also. So let's suppose whole capacity is 16. How 16 looks like in binary format is like this. How 16 represented in binary. So let's suppose here, and 1 0 0 0. So this is to the power 0 to the power 1. So this is like here, if you see 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, this is 2 to the power 4. So this is equal to 16. Now when you left shift, okay, here we can do left shift by 1, what it will become, it will take 1 0 0 0 0 0. Basically this will be shifted to this one. Okay, so here you can see 2 to the power 0 1 2 3 4 5. Now this will be equal to 32. This will be your new capacity. Okay, and what is the maximum capacity that hash map can have? Is max capacity is something which is defined like I think 1 left shift by 30. Okay, so yeah, that's kind of it about hash map. And get operation is quite simple. Okay, let's since we are doing, let's do a get operation as well. So get operation also have two cases. One is if key is null as input, so you know this has to iterate over table 0, it will give you. Okay, and if it doesn't found null key, it will obviously return null. So that's nothing to worry about. And here when the key is not null, okay, when the key is not null, what it does, it first calculate hash code of key. Okay, and then it maps the index. So maps index the same way and search in that index, because there can be a linked list or there can be a self-balancing binary tree. You never know, right? At the time of storage what happened. So it iterates over that. our table of that index. Okay, and then it checks against the hash code and equals. So here, remember, hash code checks hash code and equals. Oh, so you might have heard now that hash code and equals have a contract. Uh, if you are implementing hash code, you have to override equals as well. So this is a contract. This is why it is a contract, because if you will calculate hash code of any you know object, they might not be equal. You have to provide a definition to make a system understand that these two objects are equal, and this equals is being performed while searching that linked list, because you have given this key, right? And key is not null. So even if it finds an index, it needs to check which node actual value is, and that it will compare by equals. If given key equals to present key, okay, given key equals to the present key, present as in present in the array which you are, I mean the index which you are iterating. So that's why this contract is important here. And obviously if it matches, return the value. Okay, else returns null, I mean return null. Okay, so yeah, this is it actually about Hashmap. And if you want to follow me on even sorry if you want to follow me on LinkedIn, Instagram, where I post about all the roadmaps and I don't know why. So my ID is Thriver Ashish on Instagram, Twitter, even on LinkedIn. So I post daily on LinkedIn about something, some informative post, and on Insta also in graphical format, all the roadmaps and all. So, and Twitter also some Gyan Baji we do. So if you want to follow, you can. And the best for Hashmap. My name is Ashish Gupta.